Hi, I am Abhishek Kivesra, an applications engineer with Cypress Semiconductor. In this video, we will discuss the intellectual property security features available in a PSoC 1 device. In PSoC 1 devices, first level of IP protection is provided by controlling the access to the flash content. PSoC 1 provides 4 flash protection modes. Second level of IP security is provided by abstracting the hardware resources used and their interconnections. Programmable architecture allows functionality to be changed at runtime. There are 4 levels of flash protection: unprotected, read protect, disable external write, and disable internal write. In unprotected mode, internal as well as external read and writes are allowed. This mode is not recommended for production. In read protect mode, internal and external writes are allowed, while both internal and external reads are disabled. This flash protection mode is useful when an external programmer needs to upgrade the flash contents. In disable external write mode, only internal write is allowed. External write as well as read and internal read access is disabled. This mode is useful in the applications that need bootloader support. The disable internal write mode provides the maximum level of protection to your IP. This mode disables both internal and external read and write. To provide a fine control over the flash protection, PSoC flash is divided into sections called blocks. Each block contains 64 bytes or 128 bytes based on the device family. Each of these flash blocks can be assigned a different flash protection mode. This feature is useful when only a small portion of flash needs to be upgraded. Another example can be a bootloader based application. The bootloader area can be assigned full protection, while the upgradable area can be assigned upgrade mode protection level. PSoC Designer is the IDE used to develop applications using PSoC 1. Protection mode can be assigned using flash security file in PSoC Designer. In this file, protection mode can be assigned on a block-by-block basis. This file also explains the acronyms used for each of the protection modes. Protection modes can be changed by editing the value in the text file. Next level of IP security is provided by means of hiding the hardware resources of the system and their interconnections. PSoC devices yield highly integrated system where programmable blocks can be configured as various types of peripherals, and most of them can be connected to each other internally. These peripherals can be routed to any of the input-output pin. So system is like a black box to your competitor. Beyond integration and programmable interconnect, functionality of programmable resources can be changed at runtime. Every programmable block is configured by writing the configuration registers. These values can be modified in firmware. For instance, a continuous time block that is configured as comparator at startup can be configured as a programmable gain amplifier at a later time while executing the code. It makes it difficult to deduce the analog signal chain or other on-chip peripherals used to implement the system. Let us take an example of a system that needs few analog signals to be conditioned and digitized, a comparator for overvoltage and overcurrent, an MCU to implement the required control, and power electronics to drive the motor. If the system is implemented using discrete peripheral ICs, it will take little time for someone to reverse engineer the signal chain. If the same system is implemented using a PSoC device, it is just a black box, as any pin can be connected to any peripheral, and the ability to interconnect peripherals internally, signal chain is abstracted. For example, the system implemented using PSoC does not tell if the signal is being amplified or being filtered. In a nutshell, PSoC 1 protects firmware as well as hardware IP. Firmware IP protection is provided by means of 4 flash access modes. Protection level can be assigned at block level. It is easy to assign these modes using PSoC Designer IDE. Hardware IP security is inherited from the unique programmable architecture of PSoC devices. PSoC hides the resources used, their interconnections, and allows functionality to be changed at runtime. It leaves just a black box for your competitor to reverse engineer. For more information, download application note AN2015 from the Cypress website. Please provide your feedback to us through the survey that you will receive. Thank you for watching this video.